So in this video, we're going to be talking about rational exponents. If you remember the definition of a rational number, you remember that any rational number is a number that can be written as a fraction. Can be written as a fraction. Right? Because it's, if you think about a ratio, right, that's the same thing as a fraction. So a rational number is anything that can be written as a fraction. And so we're talking about rational exponents. And let's say, for example, that you had this number 2 to the third. Okay, so, they gave you this problem 2 to the third. Well, that would be pretty simple because this is the same thing as taking 2 and multiplying it by itself 3 times, right? 2 to the third. 2 times 2 times 2. 2 times 2 is 4. Times 2 gives us 8. Okay? You could also do this with 4. Let's say 4 squared. 4 twice, 4 times 4. And 4 times 4, right, we know is 16. Well, let's say that they gave you a negative exponent. Let's say instead of a positive exponent, let's say they gave you 4 to the negative 2. What would happen then if we did 4 to the negative 2? Well, what would happen is we would take this 4 and this 2 and we would place it under 1 in the denominator. You drop that down into the denominator. It's 4 squared under 1, or 1 over 4 squared. And we can simplify that to 1 over 16. But let's say that they gave you a fraction as your exponent instead. So instead of 4 to the negative 2, right? Instead of 4 to the negative 2, let's say that they gave you 4 to the 1/2. Let's say instead they gave you 4 to the 1/2. Now this would be the same thing as the square root of 4, which we know is 2. Okay. Now the reason for that is there's a lot of really cool things that happen when you dive deep into this. But the main reason is because if you take a look at 2 squared, we know that that is 4. So 4 to the half, right, should give you this 2, right? 4 to the half should give you 2. 2 squared gives you 4. Okay. Now let's make sure that we're being thorough here. So let's say we took instead, let's say we had 8. Let's say we did 8 to the 1/3. So we did 8 to the 1/3. And this would be the same thing as the cubed root of 8. Okay. Now, and one thing I didn't mention is that this 1 here and this 1 here doesn't go away. It stays here. And this 2 just comes nice and easy out to this square root side. This 3 and this 1 are doing the same thing. So, for example, here we have 8 technically to the first, and then you have this cube root. And what this is asking us is it wants us to find a number that can fit into 8 3 times, just like here. So if you'll remember from the beginning, right, 2 to the third gives us 8. So that would mean that the cube root of 8 should give us 2, because 2 to the third, right, 2 to the third, 2 to the third gives you 8. Okay. And we can try one more just to make sure we're being clear. So let's say we did 16 to the 1/4. Let's do 16 to the 1/4. Now that would be the same thing as taking that 16, the base, and taking the 4th root, okay, of 16. That little 1 still stays here, right? 16 to the 1 is just 16. Okay, so that goes away technically. And then we want to figure out, well, what number fits into 16 4 times? Well, 2 times 2 times 2 times 2, right? If we look here, we have 2 times 2 times 2 times 2 gives us 16. Okay, 2 times 2 is 4 times 4, right, gives us 16. So our 4th root of 16 should be 2. Okay. Now let's say that you were going to do this with an exponent. Let's say instead, or it's not with an exponent, a variable. Let's say you were going to do this with a variable instead. Let's say we had x to the third instead of 2 to the third, right? Now that's the same thing as x times x times x. And we can't simplify that anymore because we don't know what x is. We'd have to plug in a value for x. Maybe it's 2, maybe it's 4, maybe it's 16, right? But that's what this means, okay? You could also say, right, you could have x squared, right? That's the same thing as x times x, right? You could have x to the negative 2, right? You could say x to the negative 2, which is the same thing as 1 over, right, x squared, okay, which is also the same thing as saying 1 over x times x. We can break it apart like that if we have to. And you can also take these and you can use fractions as your exponents as well if you have a base as a variable. So let's use a different letter. Let's use y. And let's say we took y to the 1/2. Okay, let's say we took y to the 1/2. Now, again, we don't know what y is, so that doesn't help us out a ton, but we can rewrite it and show how this gets affected by a half exponent, right? So, for example, if we could take that and we would say that just like 4, that y to the 1/2 would be the square root of y. Okay, if you wanted to take y, or let's do a to the 1/3, right? A to the 1/3. That would mean you'd have the cubed root of a to the 1, right? And you'd have to figure out what number goes into a 3 times. And you can do the same thing with, b to the 1/4, right? You'd have the same thing as 16. You'd have that 4 over here, that 4th root, and then b would be in the middle. Okay. And so you can rewrite and use fractions the same way, as you would with regular numbers. You can use exponents to write that as well.